Hello, you are welcome. In this video, we are going to solve this exponential equation. We have m to the power of m equals 8. We are going to solve for the value of m that will satisfy this equation. Now, the first thing we are going to do is to introduce natural log. We have ln of m to the power of m, and this equals ln of 8. Now, as usual, the exponent here will come behind this ln. So we have m times ln of m equals ln of 8. Now, at this point, there is a special function that we need to introduce, and that is Lambert W function. If you have a Lambert W function of a times e raised to the power of a, this equals a. As well, if you have a Lambert W function of a fish here times the e raised to the power of a fish, this will give you a fish. Quite funny, right? But that is just it. Now we are going to apply this special function right here. But before we do that, if you look at what we have here, there must be a fish here, and there must be a fish at the exponent as well. So we need to manipulate this left-hand side of this equation to be in the form of a fish times the e of a fish. So in order to do that, the first thing we need to do is to as well rewrite this m here in form of e power ln of m. Remember, e power ln of m will give you the same thing as m, because the e here can eliminate the ln here. So this actually means m. So the next thing is we have times, we still have our ln of m, and this equals ln of 8. Now the next thing we are going to do is to change the order. We can as well decide to bring this ln of m before the e power ln of m. So let's go ahead and do that. We have ln of m times e power ln of m, and this equals ln of 8. Now look at what we have here in the left hand side of this equation. Here the coefficient is ln of m, and this corresponds to what we have here, where we have the fish, and the exponent is ln of m, and this actually corresponds to what we have here, a fish as well. So at this point we can introduce the Lambert W function. We have Lambert W function of ln of m times e power ln of m, and this equals the Lambert W function of ln of 8. So as usual, remember, if you take a Lambert W function of this, you have a fish left. So if we also take a Lambert W function of this, that means we are going to have ln of m, and this equals Lambert W function of ln of 8. Now we need to actually solve for m, so we need to try and eliminate ln here. That means we need to introduce e, like what we did here. So if you take the e of ln of m, this equals, that means you need to also introduce e here of Lambert W function of ln of 8. So this e here will eliminate the ln. That means you are going to be left with m equals e power Lambert W function of ln of 8. So this is the solution, but we need a more precise answer. So in that case, you need to visit a website. That website is wolframalpha.com. wolframalpha.com, and when you get there, you type in this E power product, you have product log. So this product log here represents the lambda array function. You have product log of ln of 8. So if you type in this, when you get to this website here, you are going to get a value, and that value will be the answer for m. That value will give that you are going to get will be, you are going to have an approximate value of 2.388. So this becomes our final answer. Now, you can as well check by inserting this value right here. So remember we had m power m equals 8. So that means if we have our answer 2.388 raised to the power of 2.388, this should give us 8 to satisfy this condition. And definitely, if you type in this into your calculator, you are going to have an approximate answer that is actually very close to 8. And this equals 8. So that is it for the video. I believe you enjoyed the class and you have learned how to use the lambda array function. Please don't forget to give me a thumbs up and share this video to your friends. Leave a comment if you feel like. Thank you and goodbye.